Okay, here we go, guys. It's going to take a while to get through all this material. All right. Today we start out by talking about extreme values. And extreme values would be the largest or smallest values. And when I'm saying the largest or smallest values, I'm talking about the y values. So not the domain, but the range values over a given interval. So if you look to the right, you can see that I have a function. It says f of x is x to the third minus 9x squared minus 48x plus 52. So as you glance at this function, this is interesting because there are what we would call kind of some maximums and minimums. For example, this one right here, we would call a local maximum. And that's because if you go anywhere to the left or anywhere to the right, the y value is going to be less than that value right there. So over the given interval, we can maybe talk about the interval from, say, -5 to 0. And you can see that, in fact, if you look at all the y values between there, this is the largest one, so we call it a local maximum. Different than what we would say a global maximum. Global maximum would actually be infinity, because if you look, this continues to head on up in this direction. So this is hardly the largest value that the function achieves, but it is locally, it is the greatest. Similarly, we have what we would call a local minimum. And that would be the smallest value within a given interval. So if you look, anywhere just to the left or anywhere just to the right, if we look at over that given interval, 5 to 10, you can tell that that's going to be the smallest y value that the function can output. Now, if you look to the left, you can see that the function goes all the way down to -infinity. So this is hardly the smallest value, but within this locality, you're definitely going to have the smallest value. So if I say local min or local max, can you get that picture in your brain? Okay. Then we're good to go for that first part. Why are we so interested? Well, let me give you these two examples. Max profit. Is that a good thing? Would you like to maximize your profit? You sure would. And so you actually have algorithms and equations that model what's happening in a company, and we try to figure out when that would be at its maximum. For example, how many units should we produce in order to create a maximum profit? How many hours should we work? How many people should we hire? All those are questions in order to maximize profit. How about this one? Would you like to minimize cost? Is that a good thing? Sure is. If we want to truly figure out how to minimize cost, again, we often model what's happening at the business. We model that algebraically, and we look for that minimum point. Now, these are kind of, business examples, but let me give you one, and then we'll move on to the examples down below. But I want you to understand how important this is, because this is pretty cool. My calculus professor, my first year of college, his name was Mike Kahn. He was a great guy, really good professor, and he used to work at the Mayo Clinic. And he worked there as a statistician, a mathematician. And he would just kind of sit around and wait for people to come to him with questions is what he would do. And one day a doctor came to him, and the doctor said that he's got a patient that's got a blocked artery. What happens when you have blocked artery? Heart attack. Why? Your blood is pumping, and there's too much pressure built up. There's nowhere for the blood to go, and what happens is the artery can't take it, and it gets a hole, ruptures. So all of a sudden you got internal bleeding. It's a bad thing, right? My grandpa, my grandma, a bunch of people in my family have died from heart attacks. I got to be careful because heart disease is an issue. So what do you do in order to alleviate that problem? You cut it, right? A bypass. You guys have all heard this, right? Somebody has quadruple bypass surgery. What you do is you cut the artery and you put a new one on, right? Oh, it gets around it. Well, why is that problematic? Well, the doctor came to my professor and he said, I want to know if this angle right here is theta, at what angle should I put the branch or the artery in order to minimize the viscosity of the blood flow? Viscosity means friction. So they wanted to create as little friction there as possible. Okay, Tara's saying, what was he talking about? This actually is a real problem, and you know, next year we could show you how to do it using calculus, but this is an example of minimizing something, and it truly changes lives. So it's not like this is something, you know, this is where, you know, people say, when do you use it? People use the concept of minimum and maximum all of the time, and you guys are going to learn how to do it as well. Kind of cool, huh? No? Maybe? Yeah. All you're thinking is heart attack. You're just thinking cheeseburger right now. Riz wants a cheeseburger, right? Isn't that you who said you couldn't live without hamburgers? Wow. Wow. What if you could have a steak sandwich? Would that be enough? Okay. All right. Well, I'm just trying to understand you better. Okay, here we go. Quadratics have extreme values. There's two types of quadratics we want to look at. This one is referred to in your book as standard form. It's the only book I know to refer to it as standard form, so cross that out. We call it vertex form. We call this standard. I did that because everybody made that mistake last year, even though I told them 15 times. If your book says standard form for something, it's referring to this. I call it vertex. Okay? And then I don't think that your book even gives a name for this type of form. But generally, this is referred to as standard form by most books. Okay? So, for example, if you were to draw an example of a parabola, that would be the extreme value. The extreme value of the parabola happens at what point? What do we call that point of the parabola? It starts with a V. Vertex. And this vertex has a location that we refer to as HK. It's the horizontal shift and the vertical shift. If we can put it in that form, we can identify the maximum or the minimum of a parabola. We're not going to work on those today. We're going to work on these. And let's say you were to graph this and it looked like that. Well, in this case, you would have a minimum. And again, it happens at the vertex. And the way that we figure out, anybody remember how you figure out the vertex for those? Negative b divided by 2a. That would be the x value. Negative b divided by twice the a value. Now, nobody remembers what this notation means after this. You should understand this. Once we have the x value, how do we get the y value? We plug it in. Plug it into the function. My pre-calculus class last year was a wonderful group, including Christy Munson. But this section was horrible, okay? And I think a lot of them just got behind in their homework. If you don't stay up with your homework on this section, life is going to be difficult for you, okay? Let's just make that very clear. So get your homework done for this section. You're going to be learning a lot of new topics. You won't be able to rely on everything that you did last year because you're going to see a lot of stuff this year that you didn't know before, and you got to make sure you do that. So, all right, if you flip through your notes, you're going to come across a page. Hey, Okay. If you flip through your notes, you're going to come across a page that looks like... Nope. 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 There we go. Now, I put this in there. I don't care what you guys do with it. If you want to rip it out or if you want to leave it there, it's entirely up to you. But you can see that I give you vertex and standard form of parabolas. I give you this chart. So here's what vertex form looks like. Here's what standard form looks like. If you want to know the direction, look at the value of A. If it's positive, it goes up. If it's negative, it goes down. If you want to find the vertex, again, I've laid it out for you right there. Axis of symmetry, X is H. Here, X is negative B over 2A. If you want to find the Y-intercept, plug in 0 for X and solve for Y. For standard form, it's just your C value. And if you want to find the X-intercepts, then you have to go through this. For this side, you do one of these three things, okay? So all that information is stuff that you've done before. You're not going to get this on the test. You need to memorize it. It's not going to be a problem. We're going to practice it a lot. But if you need a sheet of notes to kind of follow along with, you can have this, okay? Now, people wondered what's on the back side of that. I didn't want to waste just one sheet of paper and not have anything on the other side. This is just, we're going to have to factor, and some people, they want a list of all the factors, so I put list of factors 1 through 99, I think. So like if you have 84, you're wondering what are factors of 84, there they are. On the back side of that, I have divisibility tests and some factoring notes, yeah. If it's helpful, great. If it's not, it's not. And I only want to use one page. I ended up using two, so I totally defeated my original purpose. So, okay, let's go back to the original problem. Okay, it says sketch the graph of the given parabola and state the coordinates of its vertex and x-intercepts and y-intercept. Okay, so that's what we want to do. So if I'm given a parabola, first I need to recognize that both of these, we're going to say that they're in the form of y equals ax squared plus bx plus c. And I want to start by identifying the vertex. In order to find the vertex, I take negative b and divide it by 2a. The biggest mistake that people encounter is that when they look at this form, they'll say, oh, the first number is a, and the second number is b, and the third number is c. Not so. A is the number in front of x squared, b is the number in front of x, and c is the number at the end. Okay? So, what is b in this scenario? 0. There's a 0 in front of the x. You have no x term. Divided by twice a? 4. What's 0 divided by 4? 0. So, I just did negative b divided by 2a, and we have 0. Once I have 0, how do I get my y value? Plug it in. 0 squared is 0 minus 8, negative 8. There's my vertex. That's the first thing that we're asked to do. Second of all, I need to find the x-intercepts and the y-intercepts. I'm going to do the y-intercept right away. The y-intercept is whatever you get when you plug in 0 for x, which always just ends up being the constant. So the constant at the end is always your y-intercept in this form. So what's the y-intercept? Negative 8. To find the x-intercept, I now take the y value and set it equal to 0 and solve for x. So 0 equals 2x squared minus 8. Beautiful. You're solving a quadratic equal to 0. You have 3 options. What are they? Starts with F, rhymes with actor. Factor, that's one. What's the other one? CTS, complete the square, or quadratic formula. So those are your 3 options. Factor, complete the square, quadratic formula. This does factor. You can take out a 2. You're left with x squared minus 4. How does x squared minus 4 factor? Some of you will be like, I don't know if it factors or not. That's just part of it. It's like, does the number 63 factor? Well, yeah, it does. Either you know that or you don't. You got to check it against your knowledge. So my x-intercepts are plus or minus 2. You can tell from here. I should have 2 of them, as it is a squared quadratic equation. So now I plot it. Okay, so we plot our vertex, which is 0, -8. My x-intercepts are -2, +2. Does this parabola have a minimum or a maximum? A minimum. And what is the minimum value? -8. Now, we're not asked to provide that, but if you would be asked to provide that, that's all you need to do. Review from last year. Graphing parabolas. Yeah. Okay. Let's try one slightly more difficult. Y equals -1/4 x squared minus 6x plus 3. What does the negative in front do? Flip it upside down. What does the 1/4 do? Yep, a vertical shrink by a factor of 1/4. So we know this is going to be a little bit wider. Okay, that's okay. So let's figure it out. We got a vertex. How do I figure out the vertex? -b divided by 2a. What is your b value? -6. So I do -6 or +6 divided by twice the a value. Twice 1/4 is 1/2, so I have -1/2. What's 6 divided by -1/2? -12. Okay, -12. How do I get the y value? Plug it in. -12 squared, 144. Times -1/4, -36. Minus 6 times -12, -72. So I have plus 72 plus 3. -36 plus 72 plus 3. 39. There's my vertex. Got to be able to figure out the vertex. Okay. Second step. What's the y-intercept? 3. That was easy, right? X-intercept. I set the function equal to 0 and solve. 0 equals -1/4 x squared minus 6x plus 3. Does that look like it factors? Doesn't look like it, but it's hard to tell with that -1/4 in front, isn't it? A for the day, what could I multiply through by in order to... What? Close. -4. Let's multiply by -4. Very good, Skywalker. 0 times -4? 0. -1/4 times -4? X squared. -6 times -4? 24. And 3 times -4 is -12. Are there two numbers that multiply to -12 that add to positive 24? No, there are not. Not two integers anyway. So what we need to do is we need to either complete the square or use a quadratic formula. I don't like to complete the square personally. I'd rather use a quadratic formula. That's what I'm going to do in this scenario. Quadratic formula, I have it written down for you on the sheet of notes. -b plus or minus square root of b squared minus 4ac all over 2a. So -b, -24, plus or minus the square root of Anybody know what 24 squared is? 576 minus 4 times A times C divided by 2A. It's my broad shoulders, sorry. It's like when I walk through doors, I have to go sideways. Any questions where I got any of these numbers for the quadratic formula? Okay, then let's simplify. I have 576 minus 4 times 1 times negative 12. So that's 576 plus 48. 576 plus 48. 624. We would now like to try to simplify 624. I happen to know 624 is divisible by 16. 16 and 39. Leaves me with x is equal to negative 24 plus or minus 4 square roots of 39 over 2. Can I reduce that? If you factor 2 out of the top and divide, you'll be left with negative 12 plus or minus 2 square roots of 39. Those are my x-intercepts. So the question was, what are two numbers that add or multiply negative 12 but added 24? These are the two numbers. They're not rational. So they're hard to come up with on our own. Okay, negative 12 plus or minus 2 square roots of 39. Negative 12 plus or minus 2 square roots of 39. Kind of hard to plot those, isn't it? What should we do? Turn them into decimals. Very good. Let's do that. Let's get out that calculator. It's a fractal. Like that? It's a fractal. I did that just for you guys. Isn't that pretty? Looks like a Christmas. I think it looks like a wasp, a half wasp, half octopus that's flying into a fire. Do you see it, Tara? Tara sees it. Half wasp, half octopus. See the wasp? And then the octopus is obvious. And it's just always more fun if things light on fire. So, all right. Okay, negative 12 plus 2 square roots of 39. And we get 0.49. If I do negative 12 minus 2 square roots of 39, I get negative 24.49. So 0.49, negative 24.49. I'm going to write those down. Where am I? There. Okay, so 0.49 and negative 24.49. I'm going to graph these. It looks like my largest value is 39. So I'm going to go all the way up to 40. I plot my vertex, which is negative 12, 39. My Y-intercept is 3. It's going to be really close down here. X-intercept's a 0.49. That's going to be really close to the x-axis or y-axis. And then negative 24.49. So somewhere right around there. So you can see my parabola takes shape just like that. So it's going to be your job to be able to do those pieces. Parabolas that are in standard form, be able to find the vertex, the y-intercept, the x-intercepts, and graph them. Any questions? You need to stay on top of this. We don't have a lot of time. We have 3 tests in 8 weeks we need to get done in order to finish off this semester of college algebra, which you get 4 credits for. 4 college credits. So, get to your homework. Here is your homework. Section 2.6. Page 204, numbers 1 through 4 and 7 through 12. 1 through 4 and 7 through 12. For Mallory? I suppose.